All right, let's get started. Hand out the sign-in sheet. Okay, so last time we finished up chapter 9. Okay, it's probably the heaviest stuff for this section of the exam. Today we'll get into chapter 10, which is a very important section of organic chemistry, dealing with alcohols. Alcohols. Okay, alcohol is very important, used a lot in medicine and nursing and things like that. Okay, so let's get acquainted with alcohols. By first of all looking at the different types of alcohols. Okay, so let me draw some alcohols. Remember, alcohols, we have a OH in the molecule. Okay. And these can be classified as different types, such as primary, secondary, and tertiary. So what do? We go to the carbon that has the OH on it and ask what kind of carbon is that? What kind of carbon is that? Secondary. It has two carbons on it. Okay? So this here would be a secondary alcohol. What kind of alcohol would this one be? What kind of alcohol would this one be? And what kind of alcohol would this one be? Tertiary. Okay? So you want to be able to identify alcohol types. Pretty simple, isn't it? If you know how to do carbocations and radicals. Okay. All right, so this is our introduction to alcohols. Now, let's look at another introduction to them. And this will take a little bit more time on naming alcohols. What's their nomenclature? Okay. So let's get warmed up with this by looking at a series of alcohols. Let's look at these to get warmed up. So, how do we name alcohols? Well, we start with this one here. This is a 1 carbon alcohol, which remember, 1 carbon is methane. So we drop the E and add OL, so we get methanol, okay? So you probably already knew that. So alcohols carry along that ending there, okay? This one here would be what, 2 carbon or ethanol. Okay? It's interesting, if you look at these two alcohols, ethanol, as you know, can be consumed, okay? But not methanol. Take away that CH2, and this molecule becomes very toxic, okay? So you don't want to drink methanol, okay? If you use it in the lab, make sure you have gloves on so it doesn't get on your skin, because that can get in and cause damage, okay? One of the other things about methanol is that it can cause blindness, okay? So you don't want to get it in your eyes, okay? Even if you get it on you, it can absorb through your skin and go for your eyes, okay? Methanol used to be used in windshield wiping solutions, okay? So people would pour it in their car, okay? Their windows get dirty and on comes the windshield wiper stuff, okay? And they would drive with the window down and that stuff would squirt on the windshield but also get inside their car and on their face, okay? People were getting blood. So guess what they started doing then? They didn't use methanol anymore in the windshield solution, okay? So take a look on the ingredients of the stuff you use and see what's in there. If there's methanol in there, throw it away. Somebody said in the first class, when I asked them what do you think they started doing, they said they started rolling up their windshield. Right, you can do that too. Okay, so these two here, when you start getting to 3 carbons, now I've got to tell you where the OH is. So this will be 1 propanol. And down here, this would be 2 propanol. Okay? So make a note of it, starting with 3 carbons, I've got to use numbers to tell you where they are. Okay? So these two are isomers of each other. This one down here is also called isopropanol. Okay, because the OH is on the isopropyl group. Does anybody know where isopropanol is used?
Alcohol.
Rubbing
alcohol.
Rubbing alcohol. Okay. So people use it as rubbing alcohol, especially on their feet, because it evaporates easy and it leaves your feet feeling real cool. Anybody ever had their feet massaged with isopropanol? Does that feel good? Good. So you can keep that in mind. Okay, over here, what we start finding out is that the OH has priority with it. So that tells you what? I'm going to number at the end closest to it. Okay? So now the chlorine is 6. So we have 6 chloro, 2 heptanol. Okay? So again, that 2 is telling you where the OH is. Okay? Any questions on those? Those are just starters to get us warmed up there. Okay? All right, so let's continue on this priority theme, okay? Because maybe some questions are popping into your head. Such as, how would you name something like this? Okay, where now we have a double bond and an OH in the molecule. Okay, so we already learned how to name alkenes, and remember they carried some priority with them, didn't they? Well, we just learned the OH carries priority. So now we got a battle. So which one do you think carries higher priority? Any guesses? Some say a double bond, some say an OH. So let me give you the answer. The OH. Okay. So alcohols carry very high priority. They beat the double bond. Okay? So the alcohol beats the double bond. Okay? So now, how are we going to name this thing? Okay? So I'm going to name this as an alkene. Double bond begins on 4. So we have a 4 pentene. Okay? But my ending is going to be OL. And again, I can't have two vowels together. So I'm going to drop this E. And my alcohol is on the 2 carbon. So I get 2-ol. So I have 4 pentan 2-ol. Okay, does that make sense? Any questions on that one? Okay. So again, that alcohol is carrying greater priority. Okay, let's go with another example. Let's bring in the triple bond into play. Okay. We know that the triple bond has priority. Well, which do you think is going to win here? The OH will win again. Okay? So the OH is also greater than the triple bond. Okay? Just like, who do you think is going to win tonight's basketball game? Louisville or Michigan?
Michigan.
Any Louisville in here?
No.
We got one Louisville.
They gonna lose. I feel like it'd be different.
Do you think Louisville's going to win?
I really do. Upsets happen. Y'all can be upset. Next month, I win.
Okay.
You amazing, bro.
All right. So we'll see who has the priority in that game. Okay. You're going to ask me who I think is going to win? I think Louisville's going to win. You might say, why do you think Louisville's going to win?
We have higher priority.
Tell you why. And I think the teams are pretty close. And if they're close, the deciding factor is always the coach. The coach always wins. Okay, that's why Louisville beat Wichita State. Wichita State had them beat, didn't they? They had them beat by 12 points, 4 minutes to go. But Patino made the adjustments, and he won the game.
I don't think that's
All right, all right, we'll see tonight. Okay, maybe I'll be proved wrong. I'll take it.
I was gonna go to Georgia.
That's just my theory. So here, the OH carries priority, so we'll name the triple bond first. Okay, so the triple bond is YNE, but again, I have to drop the E ending and add 2 all. So here I get 4 penton 2 all. Okay, any questions on that?
Yeah, so the double bond is TYN and, excuse me, I'm sorry, triple bond, yeah, is TYN and the double bond is, yeah, TEN.
Right.
Okay.
Okay, any others? All right, let's look at one last, question.
Will the alcohol ever be attached to the same carbon as the double and triple bond?
It can be,
And you just,
it can be, and then you would number from that end. So if the OH was attached here, I would number from this end.
oh,
Okay, so you could have something like this here. Okay, so then you would get, 1 penton 2 all. All right, let's look at one last combination of this. Where now I have a double, a triple, and an OH. How can I name something like this? Okay, so again, the OH carries priority, so I'll number from its end. Okay, so we get that there. So, remember when I had a double and a triple, which did I name first?
double.
The double. The double. Okay. So here, I'll have 3 hepton. Now my triple, 6 ine. But again, I gotta drop the E because of that OL coming up. Two all. Okay. So it looks kind of strange, but it makes sense. Okay? So we get 3 hepton, 6 ene, 2 all. Okay, like enol. Like enol. Say enol. No, not enol. Okay, so a little tongue twister there. Okay, maybe you don't want to say it, just write it down and keep you out of trouble. Okay, so any questions on these here? Yeah.
You're okay to write, F 3, 10, 15, 2 all? Would that be acceptable?
Put the 3 in here?
Yeah.
You could, yeah. All right, let's look at some more alcohols. Okay, let's look at something like this here. Okay, so here we have 2 alcohols, or 2 OHs. like that. So we'd have what, 2, 3 pentane, then diol. Okay, so diols, where we have 2 OHs. Okay, I don't have to drop the E here because I got a consonant. What about something like this here? What would be the name of that? Okay, so good. They got trans. The OHs are neighbors, 1, 2. Cyclo, pentane, diol. Okay. Any questions on that one? Okay. There's 2 things of diols here. Okay, where you can have OHs on neighboring carbons and OHs on the same carbon. Okay? So if they are on neighboring carbons, what kind of diol do you think that's called? Vicinal. And if they're on the same carbon, geminal. Okay, so again, remember that vicinal means neighbor and gem means on the same. Okay. Okay, how about if I gave you this molecule here? See if you can name that one. Okay, so what do you guys get for this one here? 1. Okay, so my numbering went this way. So cyclohexene, and the double bond was on the 2 carbon. Okay. And it's an alcohol. So I need the OH. Anything else I'm missing? Okay. So I can put the 1 in here, but the 1 is understood, isn't it, on the ring? so I can leave it out, okay? Because I know the OH has the priority, so it'll always be number one. So I can leave it like this, 2-cyclohexanol. Okay. Wanted to give you these last two here. These have special names. You can name them as diols and triols. Okay. This one here has a trivial name that you'll often hear. Okay, as ethylene glycol. And this one down here has a special name as glycerol. It's a molecule found in abundance in our bodies. A lot of chemistry goes on with glycerol in our bodies. Okay? That we'll learn over time. Okay? All right, so any questions on naming of alcohols? Not too bad, was it? Okay. Well, let's move on then and look at some of the properties of alcohols. Okay. First property to look at is that of the boiling points. Okay. Let's suppose we looked at ethanol. And we wanted to look at the boiling point of ethanol. Okay. Well, when you look at boiling points, you always want to look at two of the same molecules coming close together. Something like this here. What kind of special property do you think the alcohol has? It can do what? What's that? They can hydrogen bond. Okay, so that's the big property of alcohols, if you want to remember, is that they can hydrogen bond. Okay, so what do you think that'll do to the boiling point? Make it high or low? It raises it up. Okay, so the boiling point of ethanol, for example, is about 79 degrees. Okay? So you probably found that out. Okay, you did the lab, beginning of the semester, boiling point of ethanol water mix. Well, if you took away the OH and just looked at plain ethane, okay, it has a boiling point somewhere around -40. Okay, so you see what putting on that OH does. The hydrogen bonding jacks it right up. Okay. All right, so that's the first major property to consider. Okay. Let's look at the next property. That's the property of viscosity. Viscosity. Anybody remember what the definition of viscosity was? Okay, so let's help put it into words. If something had a large viscosity, does that mean it would be something like molasses
Yeah.
or something like water? Molasses. Okay. When you think of molasses, what do you think of? Yeah, it doesn't, pours real slow, like syrup. Okay, so that's what we're looking at. We're looking at how strong it can resist flow. Okay, so if I had two molecules, let's say we showed them like this here. Okay, what I'm trying to look at is how they can flow by each other. Okay, sometimes called shear resistance. You get into engineering mechanics. Okay. So the more difficult it can do it, the higher the viscosity is. Well, what's going on between them? We got what? Hydrogen bonding there, don't we? So you think that's going to make the viscosity high or low? High. Okay. So alcohols tend to have high viscosities with them. Okay, suppose you compared those two molecules. Which of these two do you think would have a larger viscosity? The one with the more hydrogen bond. Okay, in this case, the glycerol. Okay, so in fact, if you got a bottle of glycerol, okay, what do you think it would look like? It's a clear liquid. Then when you try to pour it, it'd be real slow, wouldn't it? Okay, it's almost like a Jell-O. If you shake it, it's like a Jell-O. Okay, that's how sticky those OHs are. Okay, so when you see OHs, think of stickiness, like a piece of tape. Okay. Okay. Let's look at another property. And that is the miscibility. What does miscibility mean?
How long something mix.
Okay, think of the word mixability. Okay, so how well does it mix with something? Okay, what you're looking at is a liquid mixing with another liquid. Okay, so two liquids were miscible, what would you see? Okay, is oil and water miscible? So you'd see what, two phases there, don't you? But if two things are miscible, then you just see one phase. See that? Okay. So what we want to look at is alcohols. Are they miscible with water? Okay. Well, let's, for example, take methanol and mix it with water. Okay. Do those two have similar structures? Yeah, the OH. So water is almost a kind of a alcohol, isn't it? You have a OH in there. So here, the similar structures allow those two to mix. Okay? So methanol and water mix very, very easily, okay? Just like ethanol and water mixes very easily, propanol, and so on, okay? Let's suppose we had a molecule that looks something like that. Okay. Do you think that molecule would be miscible with water? Has an OH. Has an OH. Okay? So this end here would mix with water. But all these carbon atoms, okay, they don't have anything to do with water, do they? There's no similar structure. There's no polarity. Okay? So here, we say this end is hydrophilic. What does that mean? It loves water. It likes water. But this end would be what? Hydrophobic. What does that mean? What's phobic mean? I'm scared. Okay, so if it's scared of water, what does it do from the water? Yeah, it runs away from it. You ever been scared of somebody? You run away from them, don't you? Like a coward. So this part here does not like water, okay? But this little part here does. So overall, what would you predict? It probably wouldn't mix. What could I do to enhance it to mix? If I could somehow add some OHs in here. Okay, so if I had some chemistry to add those in there, then I could get it to mix. Okay. What do you think about glycerol? Do you think that would be soluble in water? Oh, yeah, it loves that. Okay. What's the main solvent in our bodies? Water. Okay, so this thing mixes very well in our bodies. Okay, and again, it's a main molecule, biological molecule in our body that you'll see as you study your different biology courses. Okay. Okay. Before we go, there's another kind of alcohol that's on this 3-membered ring with alternating double bonds. This is what's called phenol. We'll talk more about that alcohol in 242, okay, when we get to something called benzene chemistry, okay? But this alcohol has special properties that these other ones don't, okay? And I'll leave you on a cliffhanger what those are if you get to 242. Okay. All right, let's stop here for today. And I'll see you on Wednesday.
I got a question. We at seminar, we was talking. This girl showed us. We were talking about BBO. You know what that is? She was saying like it's like a bromide or something that they put in drinks, get the color, like the syrup and stuff to mix with like the liquid or whatever. I was just gonna actually.
Oh, yeah, I'm not familiar. It'd be good to do some research on that. Why don't you do some research on the internet there?
All right.